Hello my dear students. In this set of video lectures, I am trying to explain how to handle a compound statement that contains logical connectives. But before that, let us just quickly analyze the truth table associated with the OR logic. So, for the OR logic, if I say A and B are the inputs, and let us discuss how the outputs it's going to be. If A is 0, B is 0, then the output is 0. If A is 0, the input B is there, then the output is 1. If the A is 1, B is 0, then also the output is 1. Output is there. If A is there, B is also there, then output is there. So this is the truth table associated with OR gate. Now let us consider the truth table associated with the AND logic. Input A, B, output. So we can see that if A is not there, B is not there, then there is no output. If A is not there but B is there, still there is no output. If A is there, B is not there, still output is not there. If A is there as well as B is there, then I can conclude that there is an output. So we can see that OR logic, the output is there in 3 situations, but for AND logic the output is there only in 1 situation. Also I can see that OR logic we can stretch the possibilities, but for AND logic, since it holds true when only both the inputs are present, I cannot stretch this further. So keeping this aspect in mind, let us consider a situation. I say that P happens or Q happens, then R happens. Since I see the logic OR here, I can stretch the possibilities further. P happens or Q happens, then R happens. So if P alone has happened, then definitely R is going to happen. Q alone has happened, then definitely R is going to happen. If P happens and Q happens, then also definitely R is going to happen. Now I can also conclude that if R has not happened, then P has not happened and Q has not happened. P or Q implies R. If I swap and negate it, then I will get the negation. So if I swap the position, then it will become R implies P or Q. Then I negate it, then it will become R bar implies P or Q the whole bar. That is R bar implies P bar and Q bar. So this is one case that you have to note. Now let me present another case in front of you. It will be like R is there, that is the output R is there, then I can say that P is there or Q is there. Here I see the logic OR, which means I can stretch the possibilities further. R is there, then definitely P is there or Q is there. I am sure that R is there and P is not there. Then I can conclude that definitely Q is there. Likewise, R is there and I know that Q, the logic is not there, then definitely P is going to be there. I can conclude these two possibilities because I know that if R is there, then definitely P is there or Q is there. Not necessary that both should be there, but definitely at least one among P or Q is there. That's what I can conclude. So these two I have now derived from this logic. I cannot stretch further possibilities, so I am going to swap and negate it. Thus I can conclude that if P is not there and Q is not there, then definitely R is not there. So this is another condition that I am presenting in front of you. So far we considered the logic, that is the compound set of events with the logical connective and we have considered the OR, the logic OR that is present. Now let me present another situation in front of you. P is there and Q is there, then only R is going to be there. I see the logic AND here. I cannot stretch the possibilities further, so I am going to swap and negate. So it becomes R bar, that implies P bar or Q bar. But at this point of time I can see the logic or the moment I see it I can stretch it further. This is as good as the consideration we had, R implies P or Q, but in this case it is R bar implies P bar or Q bar. R is not there means P is not there or Q is not there. I know that R is not there, but I am very sure that P is there. Then I can conclude that Q is not there, because R not to happen, either P should not happen or Q should not happen. R has not happened, but I know that P has happened, then definitely I can conclude that Q has not happened. Likewise, I can go ahead with one more possibility. R is not there and Q is there, which definitely implies P is not there. So this is the third condition I wanted to present in front of you. Now we have got one more condition, that is R is there implies P is there and Q is there. This is the fourth condition I am presenting in front of you. I see the logic AND here. I cannot stretch the possibilities further because AND happens only in one case, so I don't have multiple possibilities here. So I can now swap and negate the possibilities, so it will look like P bar or Q bar implies R bar, which I can now further consider more possibilities because I see the logic OR here. So P has not happened or Q has not happened implies R has not happened. If I say P has not happened, I can conclude that R has not happened. Likewise, Q has not happened implies R has not happened. One more possibility, P has not happened and Q has not happened, then also R has not happened. If we observe it very closely, this logic P bar or Q bar implies R bar, it is as good as it's as good as P or Q implies R. In this case we see a negation, and that's the only difference over here. So these four conditions we should be familiar with when we are considering logical connectives with compound events. Now in the next set of videos I shall give you an explanation and illustrate these facts.